All right, apologies for that, but we'll go ahead and get started. Hello, everybody. Thank you for joining us today. My name is Danica. I'm with 3C Rent in the County of San Luis Obispo, and today we have our expert, Judy Rachel from Home Performance Pro, for our Ask the Expert on heating and cooling load calculations. Um, and this won't be our typical 3C Run webinar, but more on the office hours style session. This topic is first in our Ask the Expert series, and throughout the year, we'll also have heat pumps with Larry Waters from Electrify My Home, air tightness and ventilation with Eric Fenno with Small Planet Supply, and lastly, we have energy code and performance modeling with Grant Murphy from Inbalance Consulting. And I see you, Milos, on the comment section. Good afternoon to you as well. So before I pass things off to Judy, I just have a few logistical slides to go over. I'm sure most of you now are very familiar with Zoom, but we ask to make sure that you guys are on mute throughout the duration of the training. But if you would like to verbally participate, we will either invite you to or please raise your hand in the participant section. We encourage you to also ask questions on our chat box. And if you'd like to, please feel free to introduce yourself in the chat as well with your full name, profession, and where you are tuning in from today. And we will be addressing the questions starting with in the order of in the order that they are submitted, starting with those who has their hand raised. And lastly, the slides, it's minimal slides and recording for this webinar will be shared after the event. And I will also share this information for those who are in the chat, for those who are joining a little later. Next slide, please. So if you are new to 3C REN, we are the Tri-County Regional Energy Network, and we're a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties. 3C REN is funded by ratepayer dollars collected through the public goods charge fund in our utility bills, and the benefit of being ratepayer funded is that there's no cost to those we serve, and we are able to bring those dollars back into our region. Next slide, please. And so 3C REN currently offers 6 programs focused around 3 services. We have incentives, we have trainings, we have technical assistance. And for this webinar today, it is offered to you by our Building Performance Training Program. And if you'd like to learn more about our other services, feel free to do so by visiting our website at 3c-ren.org. And with that, I'll pass things off to Judy now to get started.
Great. Thank you, Danica. Hi, everyone. So we definitely want this to be an office hours thing where you're asking questions and I'm answering them, but you are more than welcome if you are just kind of here to hear what I might have to say. That's fine as well if you don't have any questions. So I do have some slides that I will get started on, but I would love it if anybody who has any questions would raise their hand so that we know you're there. And because I really don't want to waste time on slides if you do have questions. So this is about me, and really the most pertinent thing about any of this is that I was trained to be a trainer of the ACA load calculation procedures by the actual author of Manual J, Hank Rotowski. And so so really that's why I'm here today to answer your questions about load calculations. So this is kind of what I was thinking the agenda would be, is that I would make sure that everybody's kind of on the same page as to what a load calculation is and what the heck ACA Manual J is. And then hopefully you guys will warm up and start asking some questions. So let's begin by defining exactly what a heating and cooling load calculation is. The load calculation it's a procedure and it's based in physics and math. And all of that results in quantifying the measure of the energy needed for the heating and or the cooling system, what they need to add or remove from a space to provide the desired level of comfort. So that is what a load calculation, a heating and cooling load calculation is. So you ever think about, what the actual purpose of a building is, of what our buildings are? To a very large degree, they're really just meant to be environmental separators. One of their main functions is possessing the ability to maintain temperatures and humidities that are within the comfort zone of us human beings. So there are all kinds of environments out there, right? Um, we humans choose to live in all of them, even though the vast majority of them have some portion of the year in which we literally would not survive without having a shelter that can create, hold, and maintain a range of temperatures that are very different from the outside ambient conditions. So the load calculation tells us, based on climate and the building's construction components, how much energy any given building is going to need to keep us warm enough when it's cold outside or cool enough when it's hot outside. So I'm seeing a quick question, and it's asking, is there a means to do a load calculation similar to Manual J using CBEC Res? Manual J is an actual procedure, and so in that sense, the answer is no. Now, whether CBEC Res is hooked up to an actual Manual J procedural software that you can, whether it's click a button or somehow get to that platform that then converts what you've put into your CBEC Res model to convert it to what Manual J needs, then there's the possibility that you're going to get um, a, a Manual J load calculation out of the CBEC Res software. I'm going to say that the times that I have attempted to use the interfaces between both actual Manual J powered softwares and the energy modeling softwares, the inputs needed to do energy modeling for Title 24 are not the same as what is actually needed to do an accurate load calculation. So it's not a good way to get an actual an accurate load calculation by using the inputs in the way that you put them for energy modeling into a software. It doesn't come up with an accurate load calculation. So I hope that answers your question on that, and we can talk about that more if we need to or you'd like to. So let me move on a little bit. I'm not seeing any other questions just yet. Um, so, why do we do this whole load calculation? Well, there's a goal to doing the load calculation. And that goal is to actually provide us with the information that we need so that we can accurately select appropriately sized space conditioning equipment. We need three numbers. So the load calculation really is about producing three numbers for us, and it's these three numbers. We need the heating BTUs per hour for the building. We need the cooling sensible BTUs per hour and the cooling latent BTUs per hour. And then with those three numbers, we can start looking for properly sized equipment to meet all of those loads. And truly, it's only once we have those numbers that we can start looking for equipment to meet the loads of the building. Without those numbers, we really have no idea what capacity equipment that building needs to provide the desired level of comfort. So, we need to be able to choose equipment that will have the necessary capacity to provide the desired level of comfort without breaking the bank on utility costs. I mean, I want people to be able to actually use their space conditioning equipment and not only on really extremely hot or cold days. I want them to have their desired level of comfort within their homes. So really I need to strive to specify the smallest system possible, and it needs to be installed well so that it can manage the energy costs of the use of that equipment. What I have on this screen is the load meter that comes out of the RightSoft software. That's the software that I happen to use. It's not necessarily an endorsement of that software. It's just what I have been using since I've been doing load calculations. So this is where I see the actual loads. that I can now start choosing new equipment for. Once I have those loads, then there's a whole procedure on how to choose the proper equipment, and that means looking into the expanded performance data on the pieces of equipment. And that's what this is all about, is that this is one manufacturer's expanded performance data. And so that's where we move from the load calculation. So the load calculation is the very first step that we have to take before we can design a heating and cooling system at all. So, what exactly is a load calculation? And I'm just taking a quick look to see if there's any other questions just yet. Um, so what exactly is this whole ACCA manual J thing, right? Um, so it's literally a manual. It's literally a huge, big, thick manual. It's a manual of procedures. ACCA stands for the Air Conditioning Contractors of America. So they're a nationwide nonprofit association for professionals that install and maintain heating, ventilating, air conditioning, and refrigeration, equipment and indoor environments and all of that. So one of the things that this association does is that it writes the standards for the design, maintenance, installation, the testing, and performance of indoor environment systems. ACCA manuals, they're given letters of the alphabet. And that's just a convention that ACCA adopted to name all the various manuals they've written. Manual J is actually the most defined procedure available for completing a residential load calculation. So this is for residential load calculation. So we can't use, how we all kind of refer to it as doing a manual J, doing a manual J. That's literally ACCA's procedures for doing the load calculation is the manual J for residential. Manual N happens to be the commercial load calculation procedures. So there are different procedures depending on the type of building. And it's very important that you use the right procedures for the right building. Um, the, you know, ACCA is not the only group that's out there describing how to perform a load calculation. It's just that they've provided us with the most defined set of procedures. ASHRAE, the ASHRAE Handbook of Fundamentals, uh, amazing book, very comprehensive. But it's relating to the art of the heating and ventilation. It doesn't provide a defined procedure with us so that we can follow something um, to arrive at the load calculation result. So if you read that book, you'd get all the formulas and you'd understand what's going on and what you need to do, but it doesn't really give us kind of like procedures of how to get to that load calculation. And then there's other ways to measure the heating and cooling loads of a building. Uh, this one is using live measurements. So it's incredibly accurate. You're literally setting up a data logging equipment in a building um, on a design temperature day to truly measure how much energy is actually needed to keep that building at the desired indoor temperature. So, and I've actually named it this measured performance load calc method because as far as I know, it doesn't really have a name. And I, felt like I needed to give it a name for us to talk about it. Um, Perfectly accurate. Like, that is truly telling you how much energy the building needs. It's just not particularly practical, especially in the sense that you have to measure it, you have to do the measurements on a design day. And so considering that design days are only happen 1% of the time of the year, 1% of the hours of the year, if I had to wait for a design day for me to be able to do any load calculations, not a whole lot of load calculations are going to ever get done. So it's just not particularly practical. And so that's truly where ACCA comes in that they wrote this procedure that just really gives us kind of rules and how to get through the whole load calculation. And they went through all the issues of getting it ANSI recognized so that it is this, consensus standard. So as I said, um, the manual J is the residential load calculation, but it's specific residential. It's single family detached homes. It's only small multi-unit structures. So it's like, two, maybe three stories and very small multi-unit structures and it's really meant to be like condominiums or townhouses, not really multi-family type structures, and it can be used for manufactured homes. Um, it has no sensitivity to, what they're saying, the structural attributes, the construction details, the construction components of earth berm or earth covered dwellings. You can't use it for homes that have passive solar features. Passive solar features where we're expecting some kind of mass to hold on to energy and then release it into the building over time just completely blows the calculations out of the water. You can't use it if a home is expecting to use passive solar features. It's not going to be helpful in terms of sizing a heating and cooling system for a home like that. And then kind of unconventional construction techniques. So like straw bale or rammed earth. The earth ships that there's quite a few in New Mexico and throughout the world where they actually use basically kind of trash, bottles and cans and things like that in the walls. It doesn't apply to those kind of buildings. Um, any type of commercial activity. So even if it is technically a house, a residence, if there's a commercial activity going on in that building, it's not appropriate for that building to size their heating and cooling equipment. And then any spaces that contain a swimming pool or a spa. There's the humidity loads are so different in those buildings that the manual J load calculation procedure is not appropriate. So heat transfer itself is complicated. We know that there are the three forms of heat transfer, right? There's conduction, there's convection, there's radiation. And then there's all the building components and what all of their layers are, as well as the fact that throughout our entire houses, we're having conduction, convection, and radiation. So we need to figure out all of the heat transfer mechanisms through all of the building components. And that's what all the physics and math is that go into the load calculation procedure. So because of this, Manual J actually states that software has to be used for all but the most simple of single family residences. It's just too complicated. And so in the past, people did have to use spreadsheets and they did the best that they could, but it is recognized now that we are able to have software programs that can handle much more math much faster and in much more complicated ways, that unless it's a really simple building, which within the book it actually describes how simple the building has to be for you to be able to accurately kind of do it by hand. And, why would you want to do it by hand at this point in time? But at this point in time, we really need to be using softwares that are approved to get us accurate load calculations. And because the whole heat transfer and buildings are architecturally complex, really the load calculation procedure itself is a gross simplification of the physics and the math that's necessary to determine the amount of energy needed in a space to provide comfort. So, that being the case, it's really upon us to do the best that we can in terms of getting our inputs, getting the data that we need to put in for the procedure to get the closest approximation to accuracy that we possibly can get. And that's where what's called the site survey comes in. The site survey is what provides the input data. And a site survey for new construction means scouring a set of plans. You need to scour that set of plans. You need to ask a lot of questions for anything that's not in the plans or not clear enough in the plans um, to get the right data. And then for existing buildings, the site survey means going out to that building and figuring out all the different data points that you need, taking all the measurements that you need. Because the accuracy of the load estimating procedure is going to be only as good as your inputs, and your inputs are only as good as the job that you do on that survey. If Manual J software is not used correctly, it's going to produce an inaccurate and therefore a totally misleading answer. And truly, whether you know the procedures or not, you're going to just end up with an inaccurate load calculation. So we really need to understand the procedures. Software is amazing, it's powerful, it's useful, but it is a tool. It does not know what the right inputs are. That's what we have to know. And the software does not teach you the procedures. So unfortunately, just buying a software does not mean that you are going to figure out what the actual procedures are. It's going to just be a set of places where you can put inputs and you have to know what the correct way to measure those inputs, to quantify those inputs, what you're looking for to be able to put the right inputs in all of those places where you can put that information. So don't think that the software knows anything. It doesn't. It is on you to know and understand what you're doing. So there's consequences to not making your detailed and accurate load estimate. And so any errors that go and end up in that load calculation, and whether they're accidental or whether they're an effort to manipulate the output, those errors filter through the entire design process and they cause your installation to miss the mark, which means that you're causing comfort problems in people's homes, use of more energy than they need to be paying for in their homes. And that's all because the load calculation itself is the very, very, very first step in the entire design process that ends with the actual installation of the equipment in your home. So, have any questions come through, or do I get
Yes, we do have a question from Milos. Milo said, "Can you please explain again why is ASHRAE impractical versus Manual J?"
okay? Because ASHRAE is like telling you all the information and explaining the formulas, but it doesn't give you kind of a good way and process to come up with your load calculation. So the information is fantastic and is really part of what you should be learning and reading and understanding to do a good load calculation, but they're not giving you like they're not giving you there's not even softwares out there that are like, ASHRAE approved for coming up with an accurate load calculation. So in that sense, they're giving you the information without a path to get to our end result. So I hope that kind of explains, like the ASHRAE's information is, it's absolutely incorporated with everything that the author of Manual J knew. They're the what we have to do to a building to understand what's going on with it to come up with the load calc. Uh, that's not different, right? ASHRAE and ACCA are all talking the same building science, the same math, the same physics. It's just that ACCA has come up with an actual procedure for us to follow with like some rules to give us some guidance as to, well, how should I take this measurement? How exact do I have to be? Things like that. Um, So is Jerry's the next question? Because I'm seeing a question from
Stephen, I think Stephen goes first.
um he's kind of just making a point that um it's I'm going to say that the issue is not primarily that CBEC does not look at the room by room loads. It doesn't come up with an accurate load calculation. The the way that they input the data inputs are not put in procedurally proper and actually detailed enough to come up with an accurate load calculation. So there's the block load. There's what the entire building needs in terms of the heating and cooling, which is what that load meter that I showed you on this slide. That load meter is telling me the block load. It's telling me what the entire building needs. And then part of what we do when we're actually designing a system is that we need to look at the room by room load so that we put the right amount of energy in or take the right amount of energy out of each room individually. So that's just a drilling down for the design process as to how I'm going to put this much total energy in. How do I divvy it up between the rooms? And so that's not what the problem is in terms of an accurate load calculation. If you have an inaccurate load calculation, you're going to get inaccurate room by rooms. If you have an accurate load calculation, you're going to get accurate room by room loads. All right, so is Jerry next, as far as we know?
Yes.
Okay. So we have somebody in South Carolina. All right. Hi, South Carolina. How important is the correct R values for the walls and attic insulation for the manual J software? Okay, so we're going to start with that because then with the next one is about a blower door, which is different. Okay, so um, so the accuracy is important. The accuracy is incredibly important. The problem is that R values and the actual performance of insulation is really, really difficult to determine. And so it's so part of the guidance in Manual J is to tell us to be honest and aggressive in our determination of the actual installed components of the building, which, like it helps, but it doesn't help. But it is telling us to be honest and aggressive to the best of our ability. Um, and so I'm going to end the slideshow and see just how much trouble this ends up getting us in. But I think that I might have something that I can show you fairly quickly. I'm not sure if it's in this one. Okay, so hopefully you guys are all seeing this is a couple of knee walls. Are you seeing that, Danica?
Yes.
Okay, terrific. So this is what we are faced with. Not only so both in new construction where we have no idea how well insulation is going to be installed or not, right? So the designer might be telling me that they're going to, do the R38 in the knee wall. Um, but I have no idea if it's actually going to be installed well or not. And then in an existing building, I crawl up in an attic and I see a knee wall with, all kinds of missing insulation. The bats are not installed well. The bat on top is not, none of it's installed well. So even though this might be an R30 bat, and in this wall, these are probably like R13 or something bats, they're not performing at R13, and there's no way that this wall is performing at R13. So I have two choices. Um, I can tell the homeowner that, if we got this knee wall done correctly and well, which is what this other picture is on the other side, then actually your heating and cooling system is going to perform better. And if we kind of, make sure that there's enough improvements in your house, I can actually specify a smaller piece of equipment, which is going to cost less to run. Your house is going to be more comfortable. And or I can model your house as is, and I'm going to have to kind of make a guess as to how this wall is actually performing and do the best that I can. So insulation levels are, and the R value of them is one of the hardest parts of doing an accurate load calculation. And so what I do is other things that I can be absolutely really accurate. I'm very careful that I'm accurate about those because I know that I'm going to have a hard time coming up with what and how, what in the world I should rate this assembly as. Whereas if I crawl up in an attic and I see an assembly like this, in all probability, the homeowner has the work scope that tells me what was installed in there. I can take some measurements to get a sense of, all right, it's this thick and that's blown in insulation on the other side of that. So I can be pretty darn confident about the R value that I'm, going to be kind of figuring out when I see a well done assembly like this. So that kind of, I think, let me read the rest of your question, Jerry. But that brings me to kind of the blower door thing. Does the actual blower door test give a very different end result compared to the software? Okay, so there are no software defaults. Don't, that's part of what I was saying about software. That those default numbers are just sitting there because the software needs a number to be in that box. You need to take responsibility for knowing um, which of those boxes you need to change the numbers on, and blower door is absolutely one of those numbers that you need to change the number. You need to go out and you need to do a blower door test. And the blower door test for a load calculation is different than the typical building enclosure blower door test that we go out and do. And the difference is that in a load calculation, the duct leakage for a forced air system is a completely different component and set of math equations than the building infiltration. And that's what the blower door test is telling us is the building, the enclosure's infiltration minus duct leakage. So in a home that has a forced air system, we have to tape off all of the supplies and returns. We have to separate the forced air system from the building enclosure and do the blower door test of just the building enclosure and put that number in correctly. And then we need to figure out if there's an existing duct system that is going to be used in that house, then we need to figure out what the actual duct leakage is for that existing system. If we're changing the system out, then we need to put in what the new system, how we expect the new system to perform in terms of its insulation, in terms of its leakage. That all needs to go in a separate place in the load calculation procedure. So um, the procedures from Manual J give us actually 3 different ways to do building infiltration. So the softwares typically have various screens for you to choose which method you're going to use. I'm just going to say straight up, 2 of the methods are 100% inaccurate. There's like just so no point in using them whatsoever. They're just 100% inaccurate. Blower door is the only one that gives us accuracy, and it gives us a really good accuracy when we do the test correctly. Um, so one of them puts it on us to decide, oh, this house is loose. Oh, this house is tight. Oh, this house is semi-tight. And that's kind of the point of the blower door test is that we can't guess. We have no good way of looking at a building and knowing whether it's loose, whether it's average, whether it's tight. There are descriptions in the ACA procedures. There are descriptions of what a loose house is, what a tight house is. And believe me, if you read those descriptions, you know, it they they're very specific. They're also very broad, and there's just no good way for you to guess what in the world the house is. So that's a no-go. The next procedure is that literally you need to go through and count every single penetration that is an air infiltration leak, and you need to quantify it in some way. And so literally you need to count all the recessed lighting. You need to count all of the switch plates. You need to figure out where all the electrical penetrations and all the plumbing penetrations are going through top plates or bottom plates, where that big hole is underneath the tub in the crawl space and how big it is and how much air leakage would be going through that hole. Once again, those are just things that, you're not going to be able to figure out and be accurate about. So really we need to do the blower door test. In new construction, where we really can't do a blower door test, we really need to grill the contractor and see, have they done blower door tests on their houses? Do they have a sense of the air changes per hour from their final construction? And get a sense of how well they do or not and what they know or not. And unfortunately, in new construction, particularly with contractors that have never done blower door tests on any of their homes, we're ending up doing, wild guesses once again in terms of the infiltration of the building. And that's truly unfortunate because infiltration is really a very huge part of the loads. Uh, and so we really, really need to try to get that infiltration as accurate as possible. And so I've brought up one of my softwares, and so in the software that I use, I also get a breakdown of what the various loads are. And I know this is probably small on your screens, and I apologize for that. I can't make it any bigger, but I get a breakdown of all the different components and what the loads are. And when you end up doing a lot of load calculations, you find that infiltration is a very large part of the load. And the only reason it's probably low in this example that I have up is it's a sample that I was playing with for another class. All right, so I see that there's some more. Do you have guidance on a better calculation for passive heating loads like earth and homes? I have no idea, Jenna. I do not know what procedures there might be out there or how to figure that out. Um, yeah, the math on that of how that mass is going to store the energy and then release it. Yeah, I don't know that there is anything out there. Good luck in researching that one. So please comment definition below. Residential loads, which calculates residential design, heating and cooling loads, including room by room load calculations using ASHRAE handbook fundamental procedures to determine the proper size of the HVAC system. Would this be an accurate statement or would you add anything to this? All right, I'm sorry. I'll read it again to myself to see. I'm sorry. I don't I don't know that that's really kind of a full statement. Um, it feels like it's missing information. Yeah, like I said, so the ASHRAE Handbook of Fundamentals does not really provide a procedure. It provides all the information you need. It doesn't provide you with a procedure to like really go through. If you really dig in and understand and know their information, then you can pull all the formulas out and start looking at the different components of a building. But it's not really a procedure, and that's why that's why ACCA is so valuable. So if a home has solar panels on the roof or a Tesla Powerwall on the exterior, we should not use manual J for load calculations. No, solar panels don't go into the load calculation at all, and they don't affect the building in a way. They're just offsetting energy. And the same thing with batteries. They're just offsetting, they're storing energy. They're just offsetting energy. They don't in any way contribute to or change the climate that the building's in, the components that the building is built out of, and therefore they don't change the load on the building at all. So you absolutely, if it's a residential building and it has solar panels or batteries, you can absolutely use manual J. It's only if it has those other things. If it was built out of, rammed earth, then you can't use manual J. Um, can you please provide an example of the procedure? What is really a procedure? So a procedure is something like, I'm gonna just flip through a bunch of these slides, but literally ACA is telling us take full credit for rated performance of construction materials, installation, and construction features. Um, Manual J is telling us, oops, that was a good one, is telling us so that to measure to how to do our measurements. It's telling us that we're going to measure center line to center line of intersecting walls. So and then it's telling us to measure to the nearest half foot for the outside dimensions of exposed walls and the center line for partitions. The garage ceiling is a partition when there's a bonus room above the garage. So it's like literally telling us, just all kinds of things about how we should um, do our various measurements, how we should describe the components of the building. It gives all of this information on uh, how to do walkout basements, how to do the measurements, where they kind of feel like, you know, um, for the exterior walls that you can round off to, the nearest foot. And so you can always do better than some of the procedures, but they're giving you some boundaries to help you create an accurate load calculation. Yeah, so that's that's what a procedure is. Okay, so why is this, and in what sense does it deviate from energy modeling, providing modeling is room by room? Um, so in the energy modeling, there's a lot of defaults that are used. Um, there's a lot of things that are important that are skipped, even though they potentially could be put in the modeling. So bug screens, literally, whether you have a bug screen on the window or not, makes a huge difference in the load on that glazing. And whether that bug screen is on the exterior of the window or the interior of the window matters. The overhangs, let me see if I have this readily available. The way that we measure overhangs and measuring overhangs, here we go, uh, is critical. It makes such a difference in the load if we don't get what's called the vertical separation. So from the exterior wall to the lowest point of the overhang, that distance, as well as the distance from the horizontal projection, and then the vertical separation from the top of the window to the bottom part of the overhang. We need to measure those because they make a huge difference on the shading. The latitude of the building is incredibly important. And so we have to make sure that we're getting that right, because the latitude of the building is figured into the math of those overhangs to tell it to so that the math can be done so that we actually know what the shading is on that window. I see in energy modeling, that every single window will have a bug screen, and it doesn't denote whether it's interior or exterior. Well, I can tell you as a fact that fixed windows don't have bug screens. Um, so not every window should have a bug screen. And so if I've got a fixed window on, a south facing exposure and it doesn't have a bug screen, and there's a bunch of them, and south facing exposures often have big windows, that's a lot of surface area from an energy feature that causes a lot of load on the building to be figured incorrectly. And so when we start adding up all of those things, we just end up with inaccuracies. Okay, am I missing anything else, Danica?
No, that's it. For those that joined in, feel free to put your question in the chat or raise your hand and we can unmute you as well.
Yeah. So the location is really important. The actual latitude is really important. The elevation is really important. And those are things that, we can get, we definitely can get right. But I often see are wrong. Crazily enough, let me see if I can get to this again. Uh, in RightSoft, this kind of amuses me. Um, so there we go. So in RightSoft, when I'm choosing my design conditions, if I go into RightSoft's choices for me and I choose an ACA microclimate, and I'm pretty sure that I could choose just about any of them. We'll see what happens. Yeah. So I don't know if you guys how clear this is on your screen, but this is a location in California. California is on Pacific Standard Time. Our time zone is not -6 from Greenwich Mean Time. It's -8. What that actually tells me is that the longitude is going to be very, very wrong for this location. So when I'm picking weather data from this software, and I know that I need to be really careful to check the latitude, the longitude, and it's associated with time zones. So that's one of my biggest clues that something is wrong with this building's location. And I don't want to be designing with wrong information. That's one of those errors, accidental, that is going to filter through my entire design process. So we have to be really careful, about what's out there. And I have told this company numerous times that this is wrong, and I've yet to see it corrected over the years. So it's something that, I correct. I go in and, make a correction. Um, oops. Uh, so you just, you know what things should be, where, and it's like, you make the correction, right? So it's just you gotta just be diligent on all of this stuff. All right. Okay, so it looks like a few more things came in. Reference materials like ASHRAE manual are expensive. Yeah, they are, truly. It's amazing. I haven't seen ASHRAE stuff in the lending library, but keep looking. I suggest going in on the purchase with a colleague. That's what I did at first, is that a couple of us pitched in and bought the ASHRAE handbook, and we both used it. All right. Can you talk about how you handle oversizing systems in your work? How do you talk to customers, builders, tricks to improving right sizing? Um, I mean, how do I handle oversizing? I don't oversize. So I think you must be asking kind of something else. I have to tell people all the time that the systems that they have installed are oversized, and that when I do the load calculation that they've hired me to do, we're going to see that, I'm not going to re-specify the same size as equipment that they have out there, that they already have installed. How do I talk to customers and builders? Kind of the same way I'm talking to you. I just tell them what is and what isn't. Um, Tricks to improving right sizing. Um, just follow the procedures, understand the procedures, follow the ACCA procedures, and I think there is what's called an inherent safety factor in the Manual J procedures. And what that means is that because it is mostly because it was written by an engineer, uh, engineers are very conservative. And so there's a number of constants in particular that are in the math for figuring out like the sensible heating load. So the sensible load across anything takes into account the specific heat carrying capacity of air. And it's a constant at different elevations. There's a difference at different elevations. So at sea level, at 70 degrees, at 50% relative humidity, right? So there's actually kind of all these variables that are within that constant. Uh, the specific heat carrying capacity of air is 1.08. And that's even rounded up. In the ACCA math, that's actually rounded up to 1.1, right? So it sounds like, oh, no big deal. But the number of times that that formula itself is used is this little bit of a safety factor that trickles through the entire procedure. And so there's other formulas that have the same thing. There's just this slight rounding up to, the 10th percentile, the 10th instead of the 100th. So with all of those things, every time that piece of math is done with that little bit of adding up, we end up with what can be considered an inherent safety factor in the entire mathematics of the procedure. So if I am doing my best to be accurate and to be honest and aggressive in the way that I'm describing the building components of, in my load calculation, I'm not worried that my load calculation is ever going to spit out an undersized number for me. So I know that I can trust that I did the procedure, so it's not going to be oversized. I did the procedure properly. And B, it's not going to be undersized. It is going to be the numbers that I should be looking at to then choose my equipment. So that would be my trick to improving right sizing, is to follow the procedures and to be honest and aggressive about how I'm describing the buildings. So in my experience, the industry has software safety factors, designer, engineer safety factors, contractor safety, that end of yeah. So no, there's not. There's not any specific safety factor that's stuck into the Manual J procedures. It's just that the equations are rounded up. That is what the inherent safety factor is. There's no other safety factor that is just like stuck in. Whereas actually in Title 24, in the various softwares for them, there are factors that are put in that actually are derating things like the insulation levels that you're putting into that software. It's being derated. And then when you convince somebody to have QAI, that derate is then given back to the building. So nothing like that is happening in the Manual J procedures. There's none of these just derates because we think that people don't install insulation well. It's up to us to make that determination when we either are at a building and see how well or how poorly it's insulated, or with a new construction, how well we have a sense of that insulation is going to be installed or not. So, I think we have 6 minutes, so let's see. When you think things aren't complicated enough, yeah, totally. Does particular software have capability of entering number of occupants and adjusting outside air ventilation? Ventilation is part of the calculation. Zone information. Yeah. So outside air is an important part of what happens to the loads in a building. And so, this is just Wrightsoft's characterization of how I would put stuff in, is that if it's going to be room, then I can choose whether I'm doing just outside air, whether I'm doing heat recovery or energy recovery. If it's a central system, so it's going to be piped into a central forced air system, I also can do that. I need to put in what the efficiencies are, and I actually need to put in, so once I choose one of those, let me do that for you quickly. Since I'm in California, I'm going to do heat recovery. We're going to leave, so most of the systems are better than that. Um, so I put that all in, and then when I go into my rooms, I add the actual amount of ventilation. So I'm going to do 30 CFM, in this room and 10 CFM in that room. So you absolutely have to put ventilation in. That's a huge part of the load. And yeah, part of the procedure is occupants, appliances, but that's a really slippery slope. And there's a lot about how to put in, those are called internal gains, and they only count in cooling. And you have to think about what is logical. I'm not going to roast a turkey on the hottest day of the year, in my home. I'm not even going to probably cook a steak. I may go out to my outside grill and cook the steak. But I would not have that kind of load going on the hottest day of the year inside my house. Most of us are smarter than that to not put in all that extra heat in our home. So I wouldn't put in that my stove is running, on the hottest day of the year. Um, you should really be thinking about like July at about 4 or 5 o'clock in the afternoon, for at least for kind of that design condition. And if the adults of the house work outside of the house, they're not going to be home at 5 o'clock, 4 to 5 o'clock in the afternoon for the most part. So you don't put in either one of those people as occupants in your design. Are the kids going to be home around 4 or 5 o'clock in the afternoon on a hot day? Are they going to be out at the pool? Are they going to be out at a movie? Are they going to be out playing with their friends? So the internal gains need to be considered as happening on like that hot day in July about 4 or 5 o'clock in the afternoon. Those are the internal gains that you put in for your loads. And all that guidance is given in the ACCA manual, whereas, it's not necessarily spelled out like that in the ASHRAE information. A lot of older engineers use 400 CFM per ton. This is inefficient. Absolutely, it's inefficient. I have pulled people, I've pulled contractors throughout the entire nation, and they're all using, as a rule of thumb, they all think 400 to 500 CFM per ton. Like, think about it. I'm in Southern California. We've got the person from South Carolina on the line. We probably have people from other places, but a house here is not going to have the exact same load as a house in South Carolina or Minnesota, particularly in the winter. So you can't size by CFM per ton. Um, Totally inefficient. All right, we're at 12:59.
Yeah, just on time. Judy, do you mind pulling up the
Oh, I had the
closing
slide.
slides?
Yep, absolutely. And yeah, so let me get back to that share screen. Um, Here we go. That, away from that. Okay.
All right. Milos, we're gonna go through our closing slides real quick, and then if that's okay with Judy, we can answer that one question after. Um, so yeah, thank you so much everyone for being here, and thank you as well, Judy, for sharing your expertise with us. And I want to let everyone know that we have a code coach service that can help answer any of your energy code and calculating questions. Next slide, please. And if you have any questions regarding this course, feel free to email Chloe with the email address listed on the slide. And I did launch a survey. Did that get launched? Yes. Yes. Let us know if you like this kind of format or any feedback you have for us. This is this is our first Ask the Expert of the year, so let us know how we can improve this series. And if you are interested, we have a lot of upcoming events in our on our website, but some that I'd like to highlight are our Contractor Power Hour, which is an in-person event in Santa Barbara. We have a builder's perspective on insulation and air sealing on April Fools, and an energy performance and fire resistant construction on April 16th. And just to let you guys know, we are having our Ask the, Ex- Ask the Experts topics on heat pumps, air tightness and ventilation. And lastly, we have energy code and performance modeling. So keep an eye out for those registration links. And with that, I'll pass it back to Judy to answer Milo's questions.
So the authority having jurisdiction in California, I'm not sure what the newest code cycle says. I think that it hasn't changed. They used to allow SMACA. They definitely allow the ACA Manual J. And I think that they make a nod towards ASHRAE, um, and like I said, the math and the physics is the same. We're all talking about the same stuff. So, and just, and look it up in code if you're planning on not using Manual J. But Manual J is acceptable by code, and so that's why I stopped reading that part of code because I use ACA Manual J. So,
All right. Thank you so much, everyone, and have a great rest of your day. See you in another webinar. All right.
great. Thank you, everyone.